All right, I'm going to go crazy and I'm going to try to do this last section in the same sitting. Hopefully my cell phone holds out. So we have another set of identities. They remind you right here of all of your sum and difference identities. So there they all are, all in one spot for you to have to look at. Okay. So these were sum and difference, adding two angles and subtracting two angles. This next set of identities is double angle and half angle identities. In other words, angles multiplied by 2, that's what double means, and angles divided by 2. Those are going to be your half angle identities. Okay, so these don't take too long. So I thought, well, let's use this exploration to come up with the double angle formula that we're going to use. So if I have the sine of 2 theta, would you agree that that would be the same thing as the sine of theta plus theta? Because theta plus theta is 2 theta. I have my sine sum identity. In fact, it's right up in that box. This is my alpha, this is my beta. They just happen to be the same. So if I follow that identity, I'm going to get sine theta cosine theta plus cosine theta sine theta. Whoops. I have a squared there that shouldn't be. So this is sine theta cosine theta plus sine theta cosine theta. That is 2 sine theta cosine theta. And that is my double angle sine identity. So the sine of 2 theta is equal to 2 sine theta cosine theta. So that's an identity. Let's come up with the cosine one. And again, I'm doing these because they don't take too long. It's not too bad. So just like we just did, so the cosine of 2 theta is the same thing as the cosine of theta plus theta. So if we use our cosine identity, our cosine sum identity, where this is alpha and this is beta, you're going to get cosine alpha cosine theta minus sine theta sine theta. And that's simply cosine squared theta minus sine squared theta. That is your first cosine double angle identity. So cosine 2 theta is equal to cosine squared theta minus sine squared theta. Now, for cosine, there are actually 3 identities for the double angle. This is the first one. You can get the other 2 by using this first one, and that's what I'm going to show you how to do in C and D. So let's do cosine 2 theta. Let's start with cosine squared theta minus sine squared theta. And what you're going to do is you are going to substitute in for cosine squared theta 1 minus sine squared theta. So when you do that, you can see you're going to get 1 minus 2 sine squared theta. That is another cosine double angle identity. And then to get D, the last one, you're going to again start off with cosine squared theta minus sine squared theta. But this time you're going to leave the cosine squared theta in there. And for sine squared theta, you're going to put in 1 minus cosine squared theta. Okay, now you have to be careful here. You have to distribute through this negative. So that's going to become a negative and a positive. So what you end up with is 2 cosine squared theta minus 1, and that is your final double angle identity for cosine. And you can see down at the bottom, there they all are in a single box for you. But I've just showed you how to get them, and it only took 4 minutes, so that's not too bad. All right, now let's go ahead and use them. So here we go. Just like we did before, except this time we only need 1 triangle. So we know, I'm going to draw a little picture over here. We know we're in between pi and 3 pi halves. That's telling me where I'm in the third quadrant. I know the cosine of my theta is negative 2/5. This would be negative 2. This would be 5. Adjacent over hypotenuse. If I go ahead and if I use my Pythagorean theorem, I'm going to get that this is negative root 21. Notice it's negative because it's down. Okay, so now I'm going to use that triangle. I'm going to find the sine of 2 theta. Well, remember the sine of 2 theta is 2 sine theta cosine theta. That's the identity for sine double angle. So it would be 2 times the sine of theta, which is negative root 21 over 5. I got that from my triangle, opposite over adjacent, times the cosine of theta, which is negative 2/5. If I multiply those together, first of all, it's going to end up to be positive 4 root 21 over 25. And that is the sine of 2 times whatever that theta is. Again, we never find theta. We really don't care. This is just really practice for your identities. Cosine 2 theta. So, hey, we have 3 different identities that we can use for cosine 2 theta. It doesn't matter which one. We're going to end up with the same answer. I think I'm going to go ahead and I'm going to use since I'm given the cosine is negative 2/5, I'm going to go ahead and use the one that uses only cosine 2 theta, which is 2 cosine squared theta minus 1. So that would be 2 times cosine squared minus 1. Now you're going to get, again, the same answer no matter which one of the 3 you use. So this would be 2 times 4/25. So that would be 8 over 25 minus 1 is 25 over 25. So that would be negative 17 over 25. Again, have some fun. Use cosine squared theta minus sine squared theta and make sure you get the same answer. You should. Okay, this is our last exploration we're going to do. I'm just going to quickly show you how do I get the double angle for tangent. So just like before, this would be tangent of theta plus theta, and I'm going to use my tangent sum identity. This is my alpha, this is my beta, so it's tangent theta plus tangent theta over 1 minus tangent theta times tangent theta. Well, on the top, that's 2 tan theta, and on the bottom, it's 1 minus tangent squared theta. And that is your tangent double angle identity. Not too bad. All right, so there is an identity for sine of 3 theta. You're not going to use it, but I thought it might be fun to kind of go over how we get it, just so we can kind of have some more practice in using our identities. So what we're going to do is 3 theta can be broken up into 2 theta plus theta. Or again, this is my alpha and this is my beta. So I'm going to use my sine sum identity. So it's sine 2 theta cosine theta plus cosine 2 theta sine theta. So I just substituted in 2 theta and theta into my sine sum identity. But now I have to make a substitution in for this. Well, what is sine 2 theta equal to? Well, it's equal to 2 sine theta cosine theta, then times cosine theta, plus, now I need to make an identity switch in here. I'm going to use the 2 cosine squared theta minus 1. So cosine 2 theta is 2 cosine squared theta minus 1 times sine theta. So if I go ahead and simplify this a little, you can see that I'm going to get 2 sine theta cosine squared theta plus, I'm going to go ahead and I'm going to distribute through this sine theta. So I'm going to get 2 sine theta cosine squared theta minus sine theta. Well, check it out. Look at these. Those are like terms. So I can add them to get 4 sine theta cosine squared theta minus sine theta. And we're almost there. Notice there's still some equal signs. That's because what we're going to do is we're going to write this all in terms of sine. So where I see the cosine squared theta, I'm going to substitute in 1 minus sine squared theta. So if I distribute here, I'm going to get 4 sine theta minus 4 sine cubed theta minus sine theta, which if I combine these as like terms, I'm going to get 3 sine theta minus 4 sine cubed theta. And that is actually an identity for sine of 3 theta. So again, you don't have to know that, memorize it. I just think it's a really nice thing to have in your back pocket if you really need it. All right, let's go ahead and let's do our half angle identities. I'm going to stop this video and do one more video.